Continuing,
Division. Which class you are, Division?
I'm 6th standard, ma'am.
Sixth standard. Okay. Okay, fine. So we'll start with a chapter. Kannam, Mushkan, last class, what are we discussing? So we have been discussing organic chemistry, right? We have started with organic chemistry and we have started with raw fundamental, right, Kannam?
Yes, ma'am.
So we discussed what is carbon, what is hydrocarbon, valency of carbon, valency of hydrogen, difference between different hydrocarbons, and how to name a hydrocarbon. What is alkyl group? What is functional group? Different types of functional groups, and how to identify the functional group in a big organic molecule, after which we have discussed bond line representation of organic compound, right?
Yes, ma'am.
So I'll give you an organic compound with bond line representation. We'll say how to convert that bond line representation into a normal molecule. The basic difference between bond line representation and normal molecule is, in normal molecule we'll be representing all the atoms present in the molecule. We'll be representing all the carbon atoms, hydrogen atoms, all the heteroatoms, namely oxygen, sulfur, phosphorus, and all that, and also the chemical bonds. But in bond line representation, we'll be representing only the bonds. It can be single bond, double bond, triple bond. And if there is any heteroatom like nitrogen, oxygen, sulfur, we'll be representing that atoms only. So apart from that, definitely we will not include any carbon hydrogens in the bond line representation. So last class we have discussed one molecule and how to convert bond line representation into a normal molecule. So we'll start with that again. See, what atom can you see in this molecule? What atom you can see in this molecule? So I've represented so many chemical bonds here. Apart from that, I've represented one atom over there. Could you please tell me what atom is that? Can you see any alphabet over there? Can you see oxygen there? Or can you see the alphabet O over there?
Yes, ma'am.
Yes. So I've represented only oxygen in my molecule. Rest of the atoms are just carbon and hydrogen, but I didn't mention that. So have to convert this bond line representation into a molecule. See, in a bond line representation, every corner and every bend represents carbon atom. So the blue color dot represents carbon atom. So how many carbon atoms are there? 1, 2, 3, 4, 5, 6, and 7. So we have 7 carbons. So 1, 2, 3, 4, 5, 6, and 7. So let us number this carbon atom. So 1, 2, 3, 4, 5, 6, 7. See, I'm numbering this carbon without any rule. Actually, there is a proper rule for numbering the chain. We didn't get into the IUPAC nomenclature yet. I'm just labeling the carbon atom. That's it. So totally I have 7 carbons, and this is first carbon, this is second carbon, this is third carbon, this is fourth, fifth, sixth, and seventh. So there is a triple bond between first and second carbon. 1, 2, 3. And there is a single bond between 2 and 3. There is a single bond between 3 and 4. There is a single bond between 4 and 5. There is a single bond between 5 and 6. And there is again a single bond between 6 and 7. And the sixth carbon is connected with oxygen atom through double bond. That's it. Okay. What is the valency of carbon? How many chemical bond can a carbon atom can make? Around carbon atom, we should have four chemical bonds. It can be a single bond, it can be a double or triple bond, but definitely carbon atom should have four chemical bonds. So, as far as first carbon is concerned, how many chemical bonds has carbon atom got? One, two, three. So, to satisfy the valency, how many more chemical bonds we have to add to this carbon atom? Around carbon atom, there should be four chemical bonds. I've represented three chemical bonds here already. So, very good. We need one more chemical bond here. That's it. We are done with this first carbon. How about second carbon? Around second carbon, how many chemical bonds we have? One, two, three, four. Already four chemical bonds are there around carbon atom. So the valency of carbon is already satisfied. That's it. How about third carbon? We have left side one carbon and right left side one bond and right side one bond. So how many chemical bonds we have to add to this third carbon? Very good, very good. So one and two. And for the fourth carbon, left side we have one chemical bond, right side we have one chemical bond. Very good. Two more chemical bonds. To this fifth carbon, Kanna?
Two, ma'am.
Very good. For the sixth carbon?
One, no need, ma'am. Having
No need. Brilliant. Because already four chemical bonds are around this carbon atom. Super. How about the seventh carbon?
three, ma'am.
Very good, Kanna. One, two, three. So these bonds are satisfied using hydrogen atom. That's it. So this is the normal structure of that molecule. See, this can also be written as this is first carbon. First carbon is attached with one hydrogen. We need not put this chemical bond between carbon and hydrogen. We can write it as a condensed form. So without a chemical bond between carbon and hydrogen, I've written the atoms. Then triple bond, carbon, and this carbon is attached with this carbon, and this third carbon is attached with two hydrogens, that is CH2, and this is attached with another carbon, which is fourth carbon, and it is again attached with two hydrogen atoms, and this is attached with fifth carbon, and it is attached with two more hydrogens again, and this fifth carbon is attached with sixth carbon, and sixth carbon got one double bond O and single bond CH3. That's it. So this is the normal structure of this molecule. We are done with this. Any doubt? The Division.
Yes, ma'am.
Okay. Kana, can you able to follow this class? Okay, fine. So, what science chapter you have in your school?
Magnets, ma'am.
Okay.
Heat, ma'am.
Heat, okay.
Separation of substance, ma'am.
Very good. Separation of substances. Super. So you'd have studied sublimation, evaporation, and all that, right?
Yes, ma'am.
Okay, very good.
Ma'am, I'm Rakshan's brother, ma'am.
Okay, fine. So, was the chapter comfortable for you? Separation of substances?
Yes, ma'am.
Okay. Actually, that is one of the interesting chapters, right?
Yes, ma'am.
Okay, right. Fine. Kana, I'm just taking the raw fundamentals of a chapter called chemistry. So you just try to follow the class. That's it. Okay. You don't need to pressure yourself. You just see what is happening. That's it. That is enough.
Okay,
Okay.
ma'am.
If you get into higher classes, these small concepts will be somewhere really helpful for you. If it
Okay,
is
ma'am.
boring, also please let me know. Okay, fine. Send them, children.
Good evening, ma'am.
Good evening, Kanna. How are you?
Fine, ma'am. Happy New Year, ma'am.
Thank you, Kanna. Thank you. I wish you a very happy new year. So, how was your preparation, Sendamil children?
It's going fine, ma'am.
Okay. So, last class you didn't connect, I think, right?
Yes, ma'am.
So, we have started with organic chemistry. So, we have been discussing the fundamentals, basically discussing general organic chemistry from 11th standard. Okay. Mushkil,
Ma'am.
am I audible, Kanna?
Yes, ma'am.
Okay. I thought you disconnected from the meeting.
Yes, ma'am.
Okay, fine. So this is how you have to convert a bond line representation into a normal molecule. Okay, fine. Now we'll move on to finding the hybridization of organic compound. See, in chemical bonding, that is from your 11th standard, you would have studied how to find the hybridization of a normal inorganic molecule. But in organic chemistry, we want to discuss how to find the hybridization of organic molecule. Okay, so it is unlike your inorganic molecule. Organic compounds are quite a bigger one. So organic compounds are basically, it is made up of carbon atoms, right? So, if any organic compound is given, then we should be in a position to find the hybridization of each carbon. And that is very easy, very, very easy. So, I'll teach you how to find that. Okay. So, what is the valency of carbon? How many chemical bond a carbon atom can make?
4,
Four,
ma'am.
ma'am.
Four. So, if all the four chemical bonds are single bond, then the hybridization of this carbon is sp3. If a carbon got one double bond and rest of the bonds were single, then the hybridization is sp2. If the carbon got one triple bond and one single bond, or carbon got two double bonds, then the hybridization is sp. Just looking the carbon, we can find the hybridization. See, let us talk about this first carbon. See, first carbon got one triple bond and one single bond. So, what will be the hybridization? What is the hybridization of first carbon? Around this carbon atom, I have one triple bond and one single bond. So, what is the hybridization? If a carbon atom got one triple bond and one single bond, then what is the hybridization? sp. See, to the second carbon, we have one triple bond and one single bond. Then what is the hybridization?
SP, ma'am.
Very good, sp. How about this third carbon? This third carbon got four single bonds. So what is the hybridization of this carbon?
SP3.
Very
SP3.
good, sp3. How about fourth carbon's hybridization?
sp3.
Very good, sp3. How about fifth carbon's hybridization?
sp3, ma'am.
Very good, sp3 again. How about the hybridization of sixth carbon?
sp2, ma'am.
Yes, this is sp2. Because this carbon got one double bond and two single bonds. How about seventh carbon?
sp3.
3. That's it. So this is of each carbon in an organic molecule. Okay. If the hybridization is sp3, then the geometry is tetrahedral. If the hybridization is sp2, then the geometry is trigonal planar. Or it is triangular planar. If the hybridization is sp, then the geometry is linear. So these are the geometries. And if the geometry is tetrahedral, what will be the bond angle? What will be the bond angle? (109.5°). If it is trigonal planar, bond angle is 120°. If it is linear, bond angle is 180°. Okay. The percentage of S character. Percentage of S character. Now, what is basically hybridization? See, this is my S subshell, and S subshell got only one orbital. And this is my p subshell, and p subshell got three orbitals. These are the orbitals of an atom, so that is why it is called as an atomic orbitals. These atomic orbitals combines together or mixes with each other, and the process of mixing is called hybridization. After mixing or after getting into hybridization, these atomic orbitals will get converted into hybridized orbitals. This you would have studied in your chemical bonding chapter. See, for example, the hybridization is sp3. What it mean? One s orbital and three p orbitals were getting into hybridization. So totally one s orbital and p orbitals were involved in hybridization. So totally we'll end up with 4 hybridized orbitals. We'll end up with 4 hybridized orbitals, and the name of these hybridized orbitals are same. Name of this hybridized orbital is sp3. This is also sp3. This is also sp3. This also sp3. Initially, this orbital will have the character of only s. These orbitals will have the character of only p. But each orbitals in hybridized system will have the character of both S and P. And now we have to find what is the percentage of S character and percentage of P character in hybridized orbitals. That is very easy. See, 100 is the total character divided by how many atomic orbitals were involved in hybridization? 4. So 100 divided by 4 is 25. So each orbital is contributing around 25% for this character. So I have one s orbital and 3 p orbitals, and each orbital is contributing 25% for the character. So 25% each. So what is the percentage of s character then? What is the percentage of s character? What is the percentage of S character? 25%. And what is the percentage of P character? 25 plus 25 plus 25, which is 75%. Okay. But whenever we're talking about percentage of character, we'll be talking about only percentage of S character. because using the percentage of S character, we'll be guessing the characteristics of carbon. But whenever we are in need of percentage of P character, always we can find. Have to find that 100 minus S character will give you the percentage of P character. That's it. So here, as far as sp3 hybridization is concerned, percentage of S character is 25%. Now, as far as sp2 hybridized orbital is concerned, what will be the percentage of S character? In sp2 hybridization, what are all the atomic orbitals involving in hybridization? This is S and this is P. One S orbital and two P orbitals were involved in hybridization. So, a number of hybridized orbitals formed will be just 3. And the name of each orbital is sp2. So percentage of S character is totally 100, and we have to divide by number of orbitals involved in hybridization, which is 3. So 100 divided by 3 is 33.33%, and Sendamil Chelvan is right. So percentage of S character is 33.33%. So percentage of P character is nothing but 100 minus 33.33%. Okay. How about sp hybridized carbon? Can you please tell me the percentage of S character for sp hybridized orbital? Okay. Mushkan, how to find that, Kana? How to find that? So total character was 100, and we have to divide by which number, Mushkan? As far as sp hybridization is concerned, how many orbitals were involving in hybridization?
2, ma'am.
Very good. So 100 divided by
2.
Very good. So 100 divided by 2 is 50. So percentage of S character is 50.
50.
That's it. That's it. Okay. So we are done with percentage of S character. Next. I'll give you a representation, and I want you to tell me what you can infer from that. Carbon, single bond carbon, carbon, double bond carbon, carbon, triple bond carbon. See, this is single bond, this is double bond, and this is triple bond. As the number of chemical bonds between the atoms increases, what is happening to the bond length, or what is happening to the distance between the atoms?
It decreases, ma'am.
Yes, it is. Yes, it is getting decreased. So the number of chemical bonds between the atoms are technically called as bond order, or it is also called as bond multiplicity. So as the bond order increases, bond length decreases. Also, whenever we have a single bond, then that bond represents a sigma bond. Whenever we have double bond, one of the bonds is sigma and another bond is pi. If I have triple bond, one bond is sigma and rest of the bonds were pi bonds. If you compare the strength of sigma bond and pi bond, sigma bonds are considered to be the stronger one. Also, if you compare the bond strength of these three systems, triple bond will have, it is difficult for us to break the triple bond, and it is relatively easier to break the single bond, because as the number of chemical bonds increases, and it is really difficult to break all the three chemical bonds, right? As simple as that. That's it. So from this also we can expect a question. They may give you any normal molecule, or they may give you any bond line representation, and they may ask you to count the number of sigma bonds and pi bonds in a molecule. And have to do that. See, I'll give you a different molecule now. Could you please tell me what molecule is this? This is a very famous organic compound.
Benzene, ma'am.
Yes. And could you please tell me how many sigma and pi bonds are there?
6 and 3, ma'am.
No. See, this is just the bond line representation. If it is confusing for you, please convert this bond line representation into a normal molecule. After that, you count for number of sigma and pi bonds. So we have 6 bends over there. So we have 6 carbon atoms. Connect all the 6 carbon atoms using chemical bond and satisfy the valency of each carbon and count for this number of sigma and pi bonds.
Twelve, ma'am.
Okay. Sendamil Chelvan's answer is 12. 12 sigma bonds, right, Sendamil Chelvan?
Yes, ma'am.
Okay, we'll see. Mushkan, how many sigma bonds over there, Mushkan? Is it possible for you to count?
No, ma'am.
Are you finding it difficult? Okay, then we'll do it together. Listen here. We have 6 bends. 1, 2, 3, 4, 5, and 6. So I have 6 carbons. 1, 2, 3, 4, 5, and 6. And this is connected through single bond. This is, double bond, single bond, double bond, single bond, double bond, single bond. So as far as this carbon is concerned, this got 2 bonds here, third bond here, and it doesn't satisfy its valency, right? So the valency of this carbon has to be satisfied using 1 bond with hydrogen. Similarly for this carbon. So this is the normal structure of benzene, right? Now we'll count the number of sigma bonds. See, all the sigma bonds, all the single bonds are sigma bonds. Whenever we have double bond, 1 bond is sigma and another bond is pi. Whenever we have triple bond, 1 is sigma and rest of the bonds were pi. So as far as this bond is concerned, this is single bond. So this is first sigma bond. This is also a sigma bond. So this is second sigma bond. This is third. We have double bond here. One of the bonds is sigma. So 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 sigma bonds. And in a double bond, we have 1 pi bond, right? So this blue color bond represents pi bonds. So totally we have 3 pi bonds. That's it. So whenever a bond line representation is given, please convert that into a normal molecule to count for number of sigma and pi bonds. Okay, fine. So that's it. So we are done with hybridization and finding number of sigma and pi bonds. Now we'll move on to what is organic reaction. Okay, before getting into organic reaction, we'll discuss the classification of organic compound, where we'll be discussing about saturated, unsaturated, and very important topic as far as entrance exams are concerned is aromaticity. So we'll get into that chapter, that concept first, and after which we'll get into the organic reaction and their types. So first we'll discuss the classification of organic compound. What is organic compound? It is a compound where carbon elements are the backbone, right? So organic compound can be classified into 2 types. One is open chain, Another one is closed chain. Kana, what is open chain compound? In an organic compound, if the compound is like this, straight chain, or if the compounds are like branches got branches like this, then that is considered to be open chain organic compound where carbon atom is the backbone. As far as closed chain compounds are concerned, see, it will be like a ring. It will be like a ring. Okay, fine. Open chain compounds are classified again into two types. One is saturated, another one is unsaturated. Saturated and unsaturated. Could you please tell me the difference between saturated and unsaturated compound?
Unsaturated compounds have double and triple bond, ma'am.
So in an organic compound, if there is any double bond or triple bond, then that is considered to be unsaturated. If the compound got only sigma bonds, then that is saturated. Okay. Why it is called as saturated? What is mean by saturated compound? I'm talking about a literal meaning of saturation. In an organic compound, if we have any double bond or triple bond, then basically that organic compound got pi bonds, right? We know that pi bonds are relatively a weaker one. So we can break that pi bond, and instead of that pi bond, we can add any atom or group to the compound. So in an organic compound, further addition of atom or addition of group is possible, then that is called unsaturated compound. We can add any group or group of atoms to the organic compound. But in an organic compound, if it got only sigma bonds, then that is relatively a stronger one. We cannot break that. So to that compound, we cannot even add an atom to it. So that is why it is called as saturated. Right. And it is really easy for us to find whether the compound is saturated or unsaturated just by the seeing the structure, right? For example, among this, could you please tell me which is saturated?
First one.
First one, because we have only sigma bonds over here. Here we have triple bond, so it is definitely both the compounds are unsaturated compound, right? So just by seeing the structure, we can identify whether the compound is saturated or unsaturated. But practically, for example, if you guys are in a chemistry lab and they are giving any compound to you, maybe it can be in any solid or any liquid form, and they're asking us to find whether it is saturated or unsaturated. How to find that? We cannot see the molecule, of course. So how to find whether the compound is saturated or unsaturated? So in that situation, you have to perform an experiment to find whether the compound is saturated or unsaturated. See how to do that? First, I'll tell you the experiment and I'll tell you what is the reaction behind that. Take a test tube, add the organic sample which was given to you, to which add bromine water. Basically, bromine water is reddish orange color liquid. If you add bromine water to the organic compound, if the color of bromine water disappears, if the reddish orange color disappears, then then the organic compound is considered to be unsaturated. If the color of the bromine water retains, then that is saturated. Then the organic compound is saturated. That's it. Basically, what is happening over there? See, for suppose if I have CH2 double bond CH2, it is an unsaturated compound. To which, if we are adding bromine, what is the color of bromine? It is reddish orange color, right? This is my compound which got pi bond, and we know pi bond is a weaker one. This pi bond will break, and instead of pi bond, this bromine atom will get added to each carbon because we have two bromines, right? So each bromine will get attached to each carbon. So CH2, now single bond CH2, and each carbon is attached with bromine atom. Now, in the solution, we have no Br2 at all. If this Br2 is present, then we can see the color as reddish brown, but or reddish orange. But all the bromine were added to the compound, right? So we will not have any Br2 in our test tube. So the color will get disappeared. Okay. So this is how we can find whether the compound is saturated or unsaturated. Fine, Tanu. Any doubt? Similarly, we can use KMNO4. What is the color of KMNO4? Potassium permanganate. And what is the color of potassium permanganate? You would have seen in your chemistry lab, definitely. If you guys are definitely in your 10th standard, you have seen. Purple color. Purple. Okay. So if the color of KMNO4 disappears, again, that is your unsaturated compound. If the color retains, then the compound is saturated one. That's it. Now we'll move on to closed chain compound. This closed chain compound also classified into two types. One is homocyclic, another one is heterocyclic. Homocyclic is nothing but if a ring member got only carbon atoms, then that is homocyclic. See, here I've written only homocyclic rings. See, this is membered ring and all the members are carbon atom. Here this is 4-member ring, all the members are carbon atom. So these are cyclic rings or homocyclic compound or homocyclic chain. But if one of the ring member is not, if one of the ring members is not carbon, if we got any heteroatom like nitrogen, oxygen, sulfur, then that is considered to be heterocyclic. For example, this is a heterocyclic compound, right? Here, this is a 5-member ring, but this 5-member ring got 4 carbon atoms and 1 oxygen atom. So it is a heterocyclic compound. Okay. Again, homocyclic compounds are again classified into two types. One is aromatic compound, and another one is alicyclic compound. Here, these aromatic compounds are very, very important. Whenever an organic compound is said to be aromatic, then that represents that aromatic compounds are super stable compound. They are highly stable compound. Okay. So you can expect a question like they'll give you 2, 3 compounds and they may ask you which is aromatic. Or if the compound is not aromatic, then we should be in a position to tell whether it is anti-aromatic or non-aromatic. So we have three types of systems. One is aromatic compound. If the compound is not aromatic, then they can be anti-aromatic or they can be non-aromatic. There is a condition to find whether it is aromatic, non-aromatic, or anti-aromatic. If the compound is aromatic, as I've told you already, the stability of aromatic compound is extremely high. If the compound is anti-aromatic, then it is highly unstable. If it is non-aromatic, it is not stable as aromatic, but it is not unstable as anti-aromatic. Okay. Fine. So I'll give you the conditions. For aromatic compound, the first condition is the compound has to be cyclic. The second condition is the compound has to be a planar molecule. How to find whether the molecule is planar molecule? Check for the hybridization of each member. If it is sp2 hybridized, then that is considered to be a planar molecule. All the ring members should be sp2 hybridized. If suppose the carbon is not sp2 hybridized, but that carbon got any positive charge or any negative charge, then that is considered to be a planar molecule. Okay. Don't worry, I'll give you examples for each compounds so that you'll get comfortable. Third condition is that organic compound should have conjugated double bonds. I'll teach you what is conjugated double bond also. And finally, that organic compound should have 4n plus 2 pi electrons. Basically, if an organic compound that contains 4n plus 2 pi electrons, then that organic compound is obeying this Huckel's rule. See, this n doesn't have any physical meaning. This n can be 0, 1, 2, 3, etc. If n is equal to 1, then how many pi electrons that organic compound got? If n is equal to 0, 4 into 0 is 0. 0 plus 2 is 2. 2 pi electrons. If n is equal to 1, 4 into 1 is 4. 4 plus 2 is 6. 6 pi electrons. If n is equal to 2, then 4 into 2 is 8. 8 plus 2 is 10 pi electrons. So in an if an organic compound got 2, 6, 10, 14, etc., these many pi electrons, and that is considered to be aromatic again. Okay. So this, yes, this the alphabet n doesn't have any physical meaning, Kana. So to find these number of pi electrons, they've given you the general formula. That's it. That's it. And n can have the values from 0, 1, 2, 3, etc. That's it. The classic example for aromatic compound is benzene. Benzene is an aromatic compound. Let us see how this compound is considered to be aromatic. The first condition, the compound has to be cyclic. Is it cyclic? Is it cyclic?
Yes, ma'am.
Yes, because the compound seems to be a ring. So it is cyclic. Second one is we have to find whether the compound is a planar one. To find that, we have to find the hybridization of each carbon. So we have 6 carbons here. And could you please tell me the hybridization of this carbon? This carbon, the carbon I've marked in red color, got 1 double bond at the left and 1 single bond at the right, and 1 more bond will be with the hydrogen, right? So around this carbon atom, I have 1 pi bond or 1 double bond. So what will be the hybridization of that carbon?
sp2, ma'am.
Yes. So this is sp2 hybridized carbon. So similarly, all the carbons got 1 pi bond. So all the carbons are sp2 hybridized carbon. So definitely this molecule is a planar molecule. Then we should find whether this got conjugated double bonds. Conjugated double bond is nothing but we should have double bonds and single bonds in the alternate positions. See, double bond, single bond, double bond, single bond, double bond, single bond. So double bonds and triple bonds are alternative to each other. So this got conjugated double bonds also. Fine. Let us count how many pi electrons this compound got. See, how many pi bonds are there? How many pi bonds are there? See, this got double bond. So one of the bonds is pi. So this is also pi. This is also pi. So we have 3 pi bonds. And then 1 pi bond we'll be having 2 electrons. So how many pi electrons we got? How many pi electrons we got? There are 3 pi bonds and each bond contains 2 electrons. So how many pi electrons we got? 6 pi electrons. So it is following Huckel's rule also. So benzene is an aromatic compound. That's it. Next. For anti-aromatic, the condition is compound has to be cyclic. Again, compound has to be a planar one. Then again, we should have conjugated double bonds. But this compound will not follow Huckel's rule, which means this compound will not have 4n plus 2 pi electrons. This compound will have just 4n pi electrons. N can be 1, 2, 3, 4. Basically, this compound will have electrons, in the multiples of 4, 4, 8, 12, something like that. And here the example is could you please name this compound? How many carbons we have? How many carbons we have?
Cyclopropdiene, ma'am.
Kanna, how many carbon atoms we have, Kanna? It is not prop.
Cyclobutadiene, ma'am.
Okay. So here we have 4 carbons. So if we have 4 carbons, then that is bute. And this is a cyclic compound. So you should have a prefix cyclo. Cyclobute. Whenever we are telling about 2 double bonds or 3 double bonds, we'll be using di-tri. Whenever you're using that, you should add one more A here. So buta, 2 double bonds. So it is diene. So cyclobutadiene is the name of this organic compound. Now we'll see whether why I've written under this anti-aromatic category. The compound is cyclic and all the carbon atoms are sp2 hybridized. So that is considered to be a planar molecule. And let us see how these double bonds are arranged. Double bond, single bond, double bond, single bond. So they are alternative double bonds. So it is that, which means this compound contains conjugated double bonds also. Now we should count the number of pi electrons. See how many pi bonds we have. This is 1 pi bond and this is another pi bond. So how many pi bonds we have? 2. And each pi bond got 2 electrons. So how many pi electrons? Very good. So 4. It is multiples of 4. So it is anti-aromatic and highly unstable molecule. Now we'll come to this non-aromatic one. Non-aromatic compounds are basically cyclic, but they'll not be planar. If they are planar also, double bonds will not be in conjugation. If it is not planar or if the bonds are not in conjugation, then don't check for the number of pi electrons itself. Stop there and label that as non-aromatic compound. Okay, because if the compound is non-planar, then that is considered to be non-aromatic. Though this compound got Huckel's, which means this organic compound got 4n plus 2 pi electrons also. If it is non-planar, if that doesn't have conjugated double bonds, then that is considered to be non-aromatic. So if the second rule and third rule were ruled out, then don't check for this number of electrons at all. That is considered to be non-aromatic. See, I have this compound. Now we'll name this compound. It is a cyclic one, so we should have a prefix cyclo. And I have 5 carbons, so it is pent. And I have 2 double bonds, so it is diene. So it is cyclopentadiene. Okay. See, we didn't get into IUPAC nomenclature yet. While we are discussing IUPAC nomenclature, I'll teach you how to find the locants and all. Now, just we are writing the organic compound's name without exact rule. Whenever we are writing the I mean, whenever we are writing diene, we should tell the position of the double bond also. Since we didn't get into IUPAC nomenclature, right? I'm not getting into detail now. So here, this is a cyclic compound, definitely. Is it a planar molecule? Is it a planar molecule, Kana? How many
No.
carbon atoms we have?
Five.
5. So check for the hybridization of each carbon. This is sp2, this is sp2, this is also sp2, but this is sp3 hybridized carbon. What I told you, if the carbon is not sp2, at least that carbon should have positive charge or negative charge. But here, we doesn't have any positive or negative charge on this carbon. So that is considered to be non-planar molecule. And double bonds were also not in conjugation. Double bond, single bond, double bond, single bond, single bond. So definitely this compound is a non-aromatic one. That's it. Any doubt?
No, ma'am.
Fine. If you guys are comfortable here, please let me know. We'll move on to few more examples. Shall we move on?
Okay, ma'am.
Fine. What is the name of this compound?
Cyclopenta.
Very good. Cyclopenta. We have two double bonds. So diene. Cyclopentadiene. And just now we saw it is non-aromatic compound. Kana, in this carbon, we have two hydrogens, right? That was not represented in the bond line representation, but we have two hydrogens over there, right? What I'm going to do is I'm going to remove one of the hydrogens without a chemical bond. I'm just removing the hydrogen as H plus. So in this bond, we'll be having hydrogen's electron and we'll be having carbon's electron. Now both electrons will be on this carbon atom, but one of the electrons is carbon's electron. So carbon will not have any extra charge. But hydrogen's electron is also now, it is on the carbon. So this carbon will have a negative charge. Okay. Now I have to name this compound. How I can do is, this is a cyclic compound. So I should have a prefix cyclo. And I have 5 carbons. So it is penta. I have 2 double bonds. It is diene. But I've removed a hydrogen. Whenever in a hydrocarbon, one of the hydrogens was removed, then I have to complete using YL. So it is cyclopentadienyl. It is a negatively charged species. In chemistry, how you'll name any negatively charged species? Is it cation or anion? It is anion. So cyclopentadienyl anion is the name of this ion. Now we have to find whether this is aromatic, non-aromatic, or anti-aromatic. The first condition, is it cyclic, Kana? Yes, it is cyclic, right? Now we have to check whether the compound is planar. Now we'll see. This is sp2 hybridized planar. This is sp2 hybridized planar. This is sp2 hybridized planar. This is sp3. But what I've told you, if the carbon got any negative charge, then please consider that as a planar one. So it is a planar one. Again, we have to check whether the double bonds are in conjugation. See, listen here, very important point. Double bond, single bond, double bond, single bond, single bond. So here we have no conjugation. But whenever the conjugation is missing, in that place we have if we have any negative charge or positive charge or lone pair of electrons, then that is considered to be in conjugation. Okay. So if the double bonds were not in conjugation, or the place where the conjugation is missing, if that system got any positive charge, negative charge, or lone pair over there, then consider that as conjugated double bonds. That's it. So here the conjugation is missing, but the at that point we have negative charge, so we can consider that the system is in conjugation. Now we have to check for the pi electrons. How many pi electrons we got? 1, 2, 3, 4. See, we have to count the electron which helped for conjugation. Here this negative charge helped for the conjugation, right? So we have to include that electrons also. In this negative charge, we got carbon's electron and hydrogen's electron. So here we have 2 electrons. So how many pi electrons totally we have? 1, 2, 3, 4, 5 and 6. So we have 6 pi electrons. So all the conditions were satisfied. So cyclopentadienyl anion is aromatic. That's it. Now we'll move on to next example. Here I'm going to remove this hydrogen, but along with the electrons of carbon. So both electrons were removed along with hydrogen. So this carbon will not have any electron. It will not have its own electron, right? So carbon will have a positive charge. Kana, could you please name this compound? I want you guys to write the name of this compound. Very easy. Yes, Kana.
Ma'am, cyclopenta.
Cyclopenta. You're right. Can I please continue? You're right.
Pentadiene, ma'am.
It is not just diene. We have removed one hydrogen.
Pentadiene cation.
Very good. Cyclopentadienyl cation. That's it. Very good, Kana. Diviction, very good. And Mushkin, that was a good try. Cyclopentadienyl cation.
Because there is positive charge, that's why come cation.
Yes, yes. Here, whenever we have a positive charge on any atom or any group of atom, then we have to name it as cation. Okay, fine.
Okay.
Now we'll find whether the system is aromatic, non-aromatic, or anti-aromatic. First, the condition is it cyclic? Is it cyclic? Yes, of course, it is a ring. So it is cyclic. Now we have to find whether the compound is a planar one. To find that, we have to find the hybridization of each carbon. This is sp2, this is sp2, this is sp2. Here we have only single bond. So this is not sp2, but here we have positive charge. So what I've told you, if we have positive charge over any of these carbon atoms, then that is considered to be a planar molecule. So it is a planar one. Next, check for the conjugated double bonds. Double bond, single bond, double bond, single bond, single bond. We have no conjugation here. But what I've told you, in the place where the conjugation is missing, if we have any positive charge, negative charge, or any lone pair of electrons, then consider that as conjugation. So here, that third point is also following. Right, now we'll check for the electrons. So how many pi electrons we have? 1, 2, 3, 4. Who helped for conjugation? This positive charge. But unfortunately, positive charge doesn't have any electron. So we couldn't add these electrons, right? Because that positive charge doesn't have. But as far as second example is concerned, negative charge helped for the conjugation. And that negative charge contained 2 electrons. So we counted that, right? We included in our count. But here, though this positive charge helped in conjugation, this doesn't have any electron. So totally we have only 4 pi electrons. Now tell me, is it aromatic, non-aromatic, or anti-aromatic?
Anti-aromatic.
Yes, it is. Because we have multiples of 4 pi electrons. That's it. Now I'll give you 3 systems, and I want you guys to tell me whether which one is aromatic, non-aromatic, and anti-aromatic. But before getting into the aromaticity, I want you guys to tell me the name of each compound. Yes. Take your time. First, I want you guys to tell me the name of all the three compounds. After which you find the aromaticity.
First one non-aromatic, ma'am.
Okay, fine. You're right. It is non-aromatic. Why? You're right, Mushkin. But what is the reason behind that? Could you please justify your answer? What are all the conditions for non-aromatic compound?
Cyclic only.
This is just cyclic compound. That's it. It is not a planar one, and this doesn't have any conjugated double bonds, right? So it is a non-aromatic compound. Okay, I want to tell the name of this compound. I want you guys to tell me the name of this compound. Anybody?
Ma'am,
Name
here
of first.
having 3 carbon.
Yes, Mushkan, we have 3 carbons.
Double bond one.
We have double bond also.
Cyclopropene.
Yes. So the compound is cyclic, so we should have the prefix cyclo. Since I have 3 carbons, it is prop, and we have one double bond, so it is ene. So cyclopropene, that's it. So the compound is non-aromatic. How about second one? The name and whether it is aromatic, non-aromatic, or
Anti-aromatic one.
okay. Um, could you please justify your answer, Kanna? What are all the conditions for aromatic and anti-aromatic?
Aromatic stability.
Okay, if the compound is
Cyclic.
aromatic, then that is stable. Yes, it is cyclic.
Planar molecule, ma'am.
Okay.
Conjugated double bond, ma'am.
Yes.
Hooke's law. Hooke's rule, ma'am.
How many pi electrons this system got? How many pi electrons are there?
1 second, ma'am.
Mm.
1, 2, ma'am.
Yes, 2. We have only 2 pi electrons. Okay. Since this is positive charge, this doesn't have any electron, right? So what rule this is following?
Aromatic, ma'am.
Yes, because this follows our Huckel's rule. Because this got 2 pi electrons, right? So it is aromatic. Okay. Could you please name this compound? Diviction, very good, Kana. Your answer was right.
Anti-aromatic one.
Which one, Mushkin?
Last one.
Last one. Yes, it is anti-aromatic. Could you please justify the answer? Why it is an anti-aromatic? I mean, why it is anti-aromatic?
Conjugate double bond, ma'am.
Okay.
Planar molecule cyclic.
Mm.
They have negative charge, ma'am.
Yes, we have negative charge. Okay.
2 pi, ma'am.
Kanna, we have negative charge. So how many electrons we'll be having in that negative charge?
Two, ma'am.
In this
4 pi.
negative charge we have two electrons, and here also we have two electrons. So this negative charge helped in our resonance or in conjugation. So we have 4 pi electrons. Could you please name these systems?
Cyclopropanyl cation, cyclopropanyl anion, ma'am.
That's it. Cyclo, prop, ene, yl. Since it is positively charged, it is cation. And cyclo, prop, ene, yl, anion. That's it. Okay. Three more systems. I want you guys to tell me how many carbon atoms we have in this compound. How many carbon atoms are there in this ring?
7, ma'am.
Yes, it is 7. Very good. So we'll name this compound. Since the compound is in ring structure, it is cyclo. Since we have 7, the term is hept. And I have 3 double bonds. So it is triene. So it is cycloheptatriene. Okay. So the name for this system is cycloheptatriene. I've removed one hydrogen, so it is Yl. And since it is positively charged, it is anion.
Cation.
Very good, cation. This is cycloheptatrienyl anion. That's it. That's it. Now, please check for the aromaticity. Kanna. Check for the aromaticity. Check for the aromaticity.
Non-aromatic, ma'am.
Okay, the first compound is, yes, it is non-aromatic.
Second is aromatic, ma'am.
Okay.
Third is anti-aromatic.
Okay, whose answer was aromatic? Who told me the answer? The second one. What What was the answer, Kana? For second one, what was the answer?
Aromatic, ma'am.
Okay, it is aromatic. Mushkan's answer. Okay, right. Third one?
Anti-aromatic, ma'am.
Very good. That's it, Kana. Okay. And if we have two benzene rings connected, could you please name this compound? It is not benzene.
Biphenyl, ma'am.
No, it is not biphenyl. Kana, biphenyl is different. It is naphthalene. This is also an aromatic compound. This double bond is common for both rings. Okay, so it is considered to be aromatic. If I have three benzene rings connected, then that is also considered to be aromatic, and name of this compound is anthracene. Okay, that is also aromatic. Okay, Kana, you're getting my point?
Okay, ma'am.
Fine. Kanna, the questions, basically this aromaticity concept is very important. We can expect a question, definitely we can expect a question in Neet or JE. That important topic is this. Okay, fine. We have 15 more minutes, right? Okay. I'll give you a question and I want you guys to tell me the answer. Actually, here specifically the question is for the Vikshan. I'm going to give first priority to him. Okay. And if he couldn't answer, Senthamil Chelvan Mushkan can answer. Okay. Is that okay for you?
Okay, ma'am.
Fine. Divikshan, are you ready?
Yes, ma'am.
Okay. Because you have been in our class for last 1 hour or more than 1 hour, right? Though you are a 6th standard student, you have been in this class, and it is unfair that if I didn't discuss any 6th standard question, right? So we'll discuss at least one question from your syllabus. Here is the question. Miscible liquids such as alcohol and water can be separated by the method of dash. What is mean by miscible liquid? The two liquids which can mix with each other. Okay, that is called as miscible liquids. If you mix water and alcohol, they can mix with each other. After mixing, we cannot identify which is water and which is alcohol. Now we have to separate alcohol and water. What method we can use for the separation method, or what method we can adopt for the separation? Distillation, filtration, evaporation, decantation.
Evaporation, ma'am.
Distillation, ma'am.
Okay. Divikshan, what is distillation? For the rest of the students, this is not only for 6th standard. This we would have studied in general organic chemistry also. Separation techniques we would have, you would have seen your general organic chemistry also. So distillation, the answer is right. Whenever the two liquids are, the two miscible liquids are mixed, and whenever we have to separate these miscible liquids, we can definitely use this distillation method. See, when we can use filtration, when we can use filtration. See, this filtration method we have been using in our home also. For example, I have a water in which I've mixed any chalk powder. What I can do to separate this chalk powder from water? We can do filtration, right? When we can use evaporation, for example, I have a beaker full of water in which.
Water with salt or sugar?
Very good, very good. If I dissolve any sodium chloride, any salt or sugar, it will get completely dissolved. Okay. But whenever I'm heating the solution, all the solvent, all the water will get evaporated and salt or sugar will be at the bottom. Now we separated water from sugar. Okay. What is decanning basically? For example, I have water in which I've mixed a sand. Just by tilting, I can take this water out. That's it. The distillation method is a special one. See, I have a round bottom flask. This round bottom flask contains our alcohol plus water. We cannot find which is alcohol and which is water. They are completely miscible. But the basic difference between alcohol and water is both the liquids will have different boiling points. Whenever the liquid got different boiling points, then we can use this distillation method. We know the boiling point of water. What is the boiling point of water?
100 degrees Celsius.
Yes, it is 100 degrees Celsius. The boiling point of alcohol is definitely less than 100. Let us say it boils around 75 degrees Celsius. Now, at room temperature, basically at 25 degrees Celsius, both the components will be at the liquid state. Now, we have to separate alcohol and water. So, what I'm going to do is I'm going to heat this mixture. While I'm heating, the temperature will be rising from 25 and it will get increased to 26, 27, 28 and all that. When the temperature attains 75 degrees Celsius, which will boil, water or alcohol?
Alcohol.
Alcohol. What is boiling? That liquid will get converted into vapor. So that vapor will get escaped out. Now what I'm going to do is I'm going to close this container and I'm going to fix a delivery tube, and this delivery tube is connected with a condenser. Condenser is nothing but an outer jacket which is used for cooling the vapor which is coming out. So at 75 degrees Celsius, this liquid, the alcohol will get converted into vapor, and that only that alcohol vapor will come out and not the water, because the boiling point of water didn't attain at all, right? So here, while coming through the condenser, it will get cooled. What will happen when the vapor is getting cooled down? How it will get converted?
Will change into liquid.
Yes, again that vapor of alcohol will get converted into liquid state.